In this video, we're going to talk about families of quadratic functions. A family of quadratic functions is a group of parabolas that all share a common characteristic. The algebraic model of a quadratic function can be determined algebraically. 1. If the zeros are known, then by putting the function in factored form, leaving the variable a unknown, then we substitute in another known point and solve for the variable a. Or 2, if the vertex is known, then we'll put the function in vertex form, leaving the variable a unknown, then we'll substitute in another known point and solve for the variable a. So for instance, suppose we knew that we knew that a parabola had x-intercepts -5 and +1, and we knew that it passed through the point 3, -32, and we wanted to know the equation of the parabola. Well, since the x-intercepts are -5 and +1, one of the factors will be x plus 5, and one of the factors in factored form will be x minus 1. Notice how we're changing those signs. And we'll be able to say then that y is equal to a times x plus 5 times x minus 1. Now we need to know what the value of a is, so we're going to sub in a known point other than the 2 that we use to get it into factored form. So we're going to let x have a value of 3, and we're going to let y have a value of -32. So using this equation with the value of x and y mentioned earlier, we'll be able to say that -32 equals a times 3 plus 5 times 3 minus 1. Ultimately, then, -32 will equal a times, that should say +16, little typo there. And since -32 equals 16a, we'll be able to say that a is -2, and the equation of the parabola will be y equals -2 times x plus 5 times x minus 1. Okay, now the reason you might be curious at the start of this slide, well, why did we have to change, if we knew the zeros were -5 and +1, why did we have to change the sign when we went to put it into the factored form right here? And the sort of the final answer gives that away. If we said to you that we had this equation here and we wanted to know the intercepts of it, you would say, well, that x plus 5 could equal 0, meaning that x was equal to -5, and that x minus 1 could equal 0, meaning that x was equal to +1. So if we gave you it in factored form, you would instinctively know to change the signs, and you'd have your intercepts. So similarly, we want you to say, if we give you the intercepts, instinctively to change the signs when you put it into factored form. Okay, and that's why we do that. Now, what if we knew we had a parabola with a vertex of 227 that passed through the point 572? Well, if that was the case, because the vertex was 227, we would know that in vertex form, the equation of the parabola was a times x minus 2 quantity squared plus 27. Well, since we know the point 572 is on that parabola, we can let x equal 5, and we can let y equal 72, and we'll just state the equation with those values. Now, 5 minus 2 is equal to 3, so we'd have a times 3 squared plus 27 equal to 72. Well, 3 squared is 9, so we'd have 72 equals 9a plus 27. Ultimately, then, a is equal to 5, and we'd be able to say that the equation of the parabola was 5 times the quantity x minus 2 squared plus 27. Now, what if we knew that we had zeros at 4 minus root 5 and 4 plus root 5, and that our parabola extended through the point 5, -2? Well, what we can do is the following. As stated earlier, if we have a 0 at 4 minus root 5, then one of the factors will be x minus, then the entire quantity, 4 minus root 5. And if we have a 0 at 4 plus root 5, then one of the factors will be x minus the entire quantity, 4 plus root 5. We'll then be able to distribute that minus sign in there, and that first bracket will become x minus 4 plus root 5, and then we'll be able to distribute that minus sign, in here, and we'll get minus 4 minus root 5, and our second bracket will be x minus 4 minus root 5. We'll still have that a in front. Now, we want to distribute, so x times x is x squared, x times negative 4 is negative 4x, and x times negative root 5 is negative root 5x. Then negative 4 times x is negative 4x, and negative 4 times negative 4 is positive 16, and negative 4 times negative root 5 is positive 4 root 5. Then positive root 5 times x is positive root 5x, positive root 5 times negative 4 is negative 4 root 5, and positive root 5 times negative root 5 is negative root 25. Now at this point it looks like our question's gotten out of hand, but what's really nice about this is, first of all, we know that the square root of 25 is 5, so instead of saying minus square root of 25, we can say minus 5. And then we're going to collect like terms. Well, notice what happens. We have a plus 4 root 5, and we have a negative 4 root 5, so they cancel out. We have a negative root 5x, and we have a positive root 5x, so they cancel out. So what we end up with is x squared. Then we have minus 4x, which is minus 8x. And we have plus 16 minus 5, which is plus 11. So we see that our parabola actually has the equation y equals a times x squared minus 8x plus 11. Well, we still don't know what the value of a is, but fortunately, we still haven't used the 0.5 negative 2. So all we're going to do is we're just going to let y equal 5, and we're going to let x equal negative 2. And we're going to be in a great position after we do that to solve for a. So subbing that in, we get a times 25 minus 40 plus 11, which is a times negative 4. So ultimately then a is negative 2 over negative 4, which means a is a half. And so we're able to say that y equals 1/2 times x squared minus 8x plus 11. Now, if you go back and read the question, the original one, it actually says right here, put it in standard form. So going back to our next slide, we'll just distribute that 1/2 in. And when we do that, we get our equation in standard form, y equals 1/2 x squared minus 4x plus 11/2. Now, what if we see that we have a tunnel with a parabolic arch that's 12 meters wide? We see the height of the arch 4 meters in from the left edge is 8.8 meters. And we're curious if a truck that's 2 meters wide and 10 meters high can safely pass through. Well, right away we can think of this parabola like this, and we can say, okay, this is the point 0, 0, and this is the point 12, 0, because the arch is 12 meters wide, and we'll let this be the horizontal ground. Okay, so since one of the zeros has an x value of 0 and the other one has an x value of 12, we can say y equals a times x minus 0 times x minus 12. And then obviously x minus 0 simplifies to x. So we can say that the equation of our parabola is y equals ax times x minus 12. Well, let's see if we can find out what the value of a is. Well, we see that if we go 4 meters in from the left edge, so this is the left edge here, and we go 4 meters in from there, the height of the bridge is 8.8 meters. So we have the point 4 comma 8.8 that we know about that we haven't used yet. So we're going to sub in an x value of 4. So we'll get a times 4 minus 12. And we're going to sub in a y value of 8.8, which is right here. So 4 times 4 minus 12 is the same as negative 32. So we get 8.8 equals a times negative 32. In other words, a is 8.8 over negative 32, which simplifies to negative 11 over 40. So now we're able to say that the equation of the arch is given by y equals negative 11/40 times x minus 12. Now we're going to use a little common sense. We're going to talk about the truck. We know the truck is 2 meters wide, And we know that the truck driver is going to aim the middle of the truck at the center of the bridge in order to fit through. This is what we mean by that. If this is our bridge and the truck driver knows that he or she can barely fit through, the truck driver is going to aim the truck at the middle portion. Okay? Now, we know the middle X value is going to be 6 because it's 12 meters wide. And we see that this truck is 2 meters wide, so that means there's a meter on each side. So there's going to be an X value of 5 at one corner and an X value of 7 at the other corner. Okay, so the outer left edge of the truck will be at X equals 5, and the outer right edge of the truck will be at X equals 7. And we can tell instinctively, just using the simplest part of our brain, we can tell, you know what, this truck, if it runs into a problem, it's going to run into a problem at an X value of 5 or 7 before it runs into a problem at an X value of 6. If this truck can get under the bridge when X equals 5 or X equals 7, then the truck driver can get under the bridge entirely. And again, since this parabola is symmetrical, we can see instinctively that the height where X is 5 will equal the height where X is 7, the height of the tunnel. Okay, so all we really have to do is calculate what's the height of the bridge at either X equals 5 or X equals 7, and hope that the height of the bridge is at least 10 to let the truck that is 10 meters high fit underneath. Okay, so here we go. If there's a problem with the truck fitting under the bridge, it'll be at one of these outermost left or right edges before the middle. Therefore, if the height of the truck at X equals 5 and at X equals 7 is less than the height of the bridge, the truck will fit through. This means if the height of the bridge at X equals 5 and X equals 7 is greater than or equal to 10, the truck will fit through. And one more note, as already mentioned, the height of the arch at X equals 5 is the same as the height of the arch at X equals 7 because the axis of symmetry is at X equals 6 and parabolas are symmetric on either side. That's why we actually call it the axis of symmetry. So all we're going to need to do is plug in either X equals 5 or X equals 7 and hope for the truck driver's sake the height of the bridge is at least 10. Well, when we let X equal 5 and we sub it into the equation that we already came up with for the arch, which is this, we get some bad news for our truck driver. We get that the tunnel only has a height of 9.625, and since that height is less than 10 and the truck driver has a height of 10 of his or her truck driver can't fit underneath.